our warm-up. So for the first one, okay, we're performing the indicated operation, which is subtraction. What do we end up getting? Final answer. Rosanna? Good. Excellent. Excellent. We're subtracting, so you have to distribute the negative sign all the way through. Then for the second one, the first one here, 6x squared minus 17x plus 5. How do we factor it? Assad? What's factored form? So what? Because this is just factoring. So what multiplies to 30? Because you have to do the a times c. Okay. You probably had it right. It just sounded different. What multiplies to 30 and adds to negative 17, which were negative 15 and negative 2. Okay. What is my factored form? Yeah. Yeah, and that's what you might have had. But 3x minus 1 and 2x minus 5. So again, as a recap, okay, you replace the negative 17x with these two factors. Split the middle, 3x, you have 2x minus 5, 2x minus 5, group together the outer, and one of the parentheses. Okay, how about the next one, x to the fourth minus 16? Yeah. Excellent. Okay, you have x squared minus 4, x squared plus 4, but we also have a difference of two squares again. So x minus 2, x plus 2, and x squared plus 4. This is your final answer. You have two terms, which x to the fourth is doubled. So you have x squared times x squared gives you x to the fourth. 4 and negative 4 give you negative 16. Okay, how many of you got all three of those correct so far? Okay, all right. Then for this fourth one, what are my solutions? Liam? Okay, what did you do first?
First, I factored out the greatest common factor of 4x.
Okay.
X squared minus 2x minus 3.
Okay.
Here. So I separate 4x, which makes it equal to 0.
Mm-hmm. Good.
Focusing, and I factored out when I factored x squared minus 2x minus 3 to x minus 2 parentheses and x minus 1 parentheses.
Okay, be careful. Okay, it's what multiplies to negative 3 and adds to negative 2. So it's x minus 3 and x plus 1. Okay, so you have 3 and negative 1 as your other two solutions. So you always want to look for greatest common factor first, which here, pretty simple, was 4x. Once you factor that out, you're left with x squared minus 2x minus 3. But you are looking for solutions. So 4x you can't get rid of. All right. Also, what is our degree? 3. So how many solutions should we have? 3. Okay, so if you eliminate that 4x, then you don't have that, you're missing a solution there. All right. Any questions on these four? Then if you look at the graph to the right and you had to list the zeros, just based off the graph, what are my zeros? What are my zeros? Genevieve. Good. Negative 4, negative 2, positive 1. Because these are your x-intercepts, which are also zeros, which are also solutions. Is this degree odd or even? Wes? Odd. Why? Excellent. The arrows are not going in the same direction, and if you were to expand or flatten it out, it would resemble a line, okay? Is the leading coefficient positive or negative? Looking at the graph, left to right, is it increasing or decreasing as a whole? Wes? Increasing, so it's a positive leading coefficient. As you look from bottom to top, it's increasing. Now, we're just estimating here our max and mins, okay? What would be the maximum, roughly? Danielle? Y equals 4, good. And what is our minimum? Liam? Y is equal to negative 8. Okay. Today we're actually going to find the actual max and mins of these guys, okay, using our calculator. So then what we left off at before break was our end behavior, okay? Be careful of the notation. You always want to look below, okay? As x approaches positive infinity, so this is different. As x gets larger, where's my arrow heading? What's that? Upward to positive infinity. As x gets smaller, so as we move to the left, where's my arrow going? Sawyer? Negative infinity. So you have to pay attention to what is being asked, because they could switch. We've seen a lot as negative infinity comes first, but some cases, some practice has the positive going first. So be careful what's underneath the limit. Okay? Any questions? Right. You guys started before break on page 5 of your packet. Okay, and we're going to recap. We're going to go through this practice pretty quickly because some of you did start it. Okay, this is on page 5 of your 2.9 graphing packet. Okay, your graphing packet looks like this. Okay. That's okay. Okay, the 2.9 graphing packet, which I'll hold it up so you guys can see. This one. Okay, it's the pretty thick one with 22 pages. Okay. If you turn to page 5 to practice, this was towards the end, so you guys didn't get much done. You probably did the first 3, 4 maybe. Okay, but as a recap, all right, and you have your answers in front of you, those of you that got through some of it. For this first part, what is our degree? Yeah, Taylor. 4, which is even. Is our leading coefficient positive or negative? What? Positive. Okay. The number of turning points would be what? Danielle? 3. Remember, turning points is 1 less than the degree, the maximum number of turning points. So now the end behavior. This is even, and if it's positive, is it going to resemble a line or a parabola? A quadratic. Yeah, Sawyer. Careful. Parabola, right? It's even, meaning x to the 4th. So it's either going to have both arrows going up or both arrows going down. Which one would it be? Both going up. So therefore, their end behavior is going in the same direction, which is to where? Positive infinity. Okay. Now if we look at B, what is our degree? Wes? 3, which is odd. Okay. Leading coefficient would be what? Addison? Negative. It's -1, so it's negative. Number of possible turning points. Nolan, what do you think? 2. Good. Okay, so this is odd. Is it going to resemble Quadratic or a line? Ma'am?
A line.
A line. Increasing or decreasing line?
Decreasing line.
Decreasing line. So it's going to look something like this, right? Now, as x approaches negative infinity, where is y heading to? Danielle? Infinity. Good. As x approaches positive infinity, where are we heading? To where? Negative infinity. Good. Okay. Now for C, what is my degree, Esteban? 6, which is even. Jack, what's my leading coefficient? Yep. -2, which is negative. Blake, how many turning points? Number of possible turning points is 1 less than the degree. Okay. So, since this is even, quadratic or line? Quadratic, right? Both going up or both going down? Where are we going? Down. Good. Okay. Questions on that first part? Okay, and again, it's just a recap. Yes?
So why do they go down again?
What?
Why exactly is the end behavior result?
Because it's even, negative leading coefficient. So it's going to look something like that. Okay? So then finding solutions, which are also our zeros. For number 1, what's my 0? Danielle? 5. Okay. For number 2, what are my solutions here? Braden? 0 and 8. Okay. For number 3, Sad? 7 and 2. Okay, good. Now number 4, what do we have? Danielle? Good. All right. Now 5 and 6, you had to factor. Okay. So for number 5, how would I factor that? Caitlin? Good. So therefore, what are your 2 zeros? Good. Excellent. Okay. Number 6, you had to factor by grouping, by splitting the middle. What would it be in factored form? Rosanna? Good. So when we split the middle, x squared, x minus 3 plus 1, x minus 3. So if we're talking about solutions, okay, or zeros, we have 3 and plus or minus I. Okay? 3 and plus or minus I. Right? So now this was a new part for us in terms of multiplicity. Okay? That's where the cubes, terms, or squared factors come into play. So for example, number 1, we already know this is a 0 of 5. But at 5, is it crossing or touching? Meaning bouncing off. Is it crossing through the x-axis or bouncing off? Danielle? Why? Multiplicity. Yeah. So the multiplicity here is 3, because the exponent is 3. If this factor, God bless you, has an odd exponent, it will be crossing the x-axis. Okay? If we look at number 2, we know the zeros from the previous section were 0 and 8. But x has an exponent of 1. So is that touching or crossing? Crossing. However, 8 has a multiplicity of what? 2. So what would it be doing? Check. Touching. Good. So when you touch, you have a multiplicity of 2 or 4 or 6. Okay. So then for number 3 was 2 and negative 7. At 2 and negative 7, what's happening? For both. This one? They're both crossing. Okay? And we already know these zeros. That's why I'm going pretty quickly with this. Negative 5 halves and 3. Negative 5 halves, what's happening? Liam? Good. At 3?
It's touching.
Good. And then for number 5, we know the two zeros, negative 6 and negative 1. Both are doing what? Check. Excellent. Good. Now number 6 is a little different. Okay. We had 3 and plus or minus I. At 3, what's happening? Danielle? Crossing. However, plus or minus I, is it doing anything? Why not? I see a lot of you shaking your heads. Sawyer? Excellent. It's imaginary, so you can't see it. Okay? So you won't circle anything here. Okay? In the last section, before we move on to some other graphing stuff, okay? Writing equations. A polynomial has an odd degree and a negative leading coefficient. So odd degree, negative leading coefficient. It has an x-intercept at 5 with a multiplicity of 2, x-intercept at negative 3 with a multiplicity of 1. Sketch and write an equation. So how would I write this? How would I write x-intercept at 5 as a factor? What would that look like? Addison? Good. X minus 5 would be the factor, but since it has a multiplicity of 2, I'm tacking on the squared term. Okay. How would I write x-intercept at negative 3 with a multiplicity of 1? Liam?
Just parentheses x plus 2.
Good. What else do I have to add to this equation? Check. Good, you need the negative. So when we graph these, and again, rough sketch, at negative 3, what's happening? Touch or cross? Rosanna? Cross. At 5, what's happening? Danielle? Touch. And it's negative and it's odd. So is it going to resemble a line or a quadratic? What? A line. So, again, negative line. We're crossing at negative 3. And then we're bouncing at 5. So this is what a sketch would look like. Again, it's a sketch. We're going to find the actual today. Okay. So there's some of you that didn't get to, okay, 2 and 3. Okay. 3's graph ended up here, so just write it right there. What I want you to do is take a minute to write your equations and sketch your graph at 2 and 3 if you haven't done so already. Okay. So number 2 and number 3. Go ahead. All right, let's look at number 2. What would my equation be? Danielle. Good. And again, it doesn't matter what order your factors are in. Okay, if you had x minus 1 squared, and then x plus 4 squared, you're still good. Still a positive leading coefficient. What is happening at negative 4? Touch or cross? Sawyer. At 1. Also touch. Good. And is it going to be a quadratic or a line? Liam?
It's going to be quadratic.
Good. So we have negative 4, and we have 1, and it's positive. So a little rough sketch. Looks like that. Okay, and again, rough sketch. Now for number 3, what's my equation? Caitlin. Good. Excellent. Okay, at negative 2, what's happening? Touch or cross? Taylor. At 7? Good. Perfect. All right. Odd degree, positive leading coefficient, so it's going to resemble a what? Rosanna. Line. Thank you. Okay. So we have crossing, negative 2, touching, there we go. Okay. How many of you did get both of those correct? All right. Awesome. So we did all this. If you turn to 2.9 practice, which looks like this, and it should be on page 9 of your notes. Okay, so this is page 9. Now, we are tying everything we have done. So including, if you look at the bottom, increasing, decreasing, positive, negative. Okay, so right now, you already know, and you know a lot more, but just for now, I want you to find, using our equation, x squared plus 6x plus 5, I want you to find the degree and the name, factored form, y-intercept, x-intercepts, and your end behavior, based off of this equation, okay? We are then going to use our calculators for the rest, right? Go ahead, try those 5. All right. Looking at, we have x squared plus 6x plus 5. What is our degree, and what's the name of the degree? Who's got it? Sawyer. Perfect. Degree is 2, and it's a quadratic. What would factored form be? Danielle? Good. Okay. What is my y-intercept? How do we find the y-intercept if we need to know it? Todd? So what would it be? 5. So our y-intercept is 0, 5. What are my x-intercepts? Danielle? Negative 5 and negative 1. Okay, so I'm just going to plot those. Okay. Now, knowing my degree, knowing my leading coefficient is positive. As x approaches negative infinity, so as we move to the left, where is y heading? West? Okay, good. As x approaches positive, what's happening? Go ahead. Infinity as well. Okay, so it's going to resemble, it is actually a quadratic, so both are going up. So take out your calculators. Okay. If you don't have one, this is recorded. So if you need to look back later, you can. We saw some of this already before. Right. Now, I'm going to show you how to, number 1, reset your memory, because you will have to do this before and after your midterm. Okay? So before and after your midterm, I will be checking this to make sure your history is cleared. Okay, so what we do, so everyone starts at the same spot, second plus sign. Oops. Again, mine's a little. Second plus sign. 7, 1, 2. Second plus sign, 7, 1, 2. Okay. What that does is just brings you to the normal screen. Everything's all set, so you don't have to sit there and clear and make sure things are turned off. All right. So now go to y equals, which is above the second key. And we're going to type in our equation, x squared plus 6x plus 5. So to find the x, it's below the mode key. Okay. Your squared term is above the log key on the left. Okay. Plus 6x plus 5. Everyone okay? Okay, press graph. So, you see your 2x intercepts, you see your y-intercept here. Now, I'm going to show you two different ways to find, what do we have, a max or min shown? What do we have? A minimum, right? So, one way, go to second, trace. It brings you to the calculate screen. You must hit second trace or else it's just going to trace it all over, right? Second trace brings you to calculate. We're going to type in number 3. Just press number 3. Now, the first way I'm going to show you, where it says left bound, I'm going to use my x-intercepts to help. Here's the minimum. So I'm going to choose an x value to the left of that. Well, I know one of my x-intercepts is -5. So I'm going to type in -5. Just type it in, hit enter. Then it says right bound. My other x-intercept is -1. I could have used -4 or -2, but I'm using what I know. So -1, hit enter. Then it says guess. Hit enter again. Okay, this gives you a minimum, and we're rounding to 100ths place, but this is pretty straightforward. -3, -4 is your minimum. Okay, that's one way, by using your x-intercepts. And remember, you are not done unless it says minimum. Okay, the other way is, which some of you know already, if I go to second trace, number 3 minimum, and say it says left bound. So I'm going to slightly move my cursor to the left of that minimum. I'm going to hit enter. Then it says the right. I'm going to move my cursor to the right. I'm going to hit enter. Then it says guess. I'm going to hit enter. And it gives me the same thing. Okay? So those are two different ways. If you're not comfortable using the x-intercepts and want to do left and right, go ahead. You got the same thing. I used to do it this way until I was shown the x-intercept way, which is kind of, it's easier if you could see it. All right? So once we have our minimum, there's no max. Once we have our minimum, we're going to jot it down here. -3, -4. We're also going to put it on our graph, and you guys could see yours better than I could see this. Okay. And we're going to answer these questions. So, where am I increasing? From where to where? Yep. Good. -3 to infinity. Where am I decreasing? Danielle? Good. So, I meant to mention before, normally for our max and mins, we already always show our y values, right? But don't you need your x values to help you with this, right? So when you see increasing, decreasing, positive, negative, make sure you jot down the point, okay? Where am I positive? Where is this graph positive? Wes? Okay, it's an interval, so be careful. So how am I writing it as an interval? So -5 and -1 are correct. They're part of it, right? So from where to where is this positive? Yep. Good. And who remembers what do I have to put in between, Rosanna? The U for union. Okay, good job. Where am I negative? Addison. Good, -5, -1. Okay. Does this graph bounce off the x-axis at all? No. Where does it cross? Danielle? Good. What is the domain of this function? What is the domain? Jackson, what's the domain? Good. Let's see. Lila, what's the range? Perfect. Excellent. -4 with the bracket to infinity. Okay. What is the degree of this function? What? 2. How many times does it change direction? Addison? Once. Is this degree even or odd? Yes. Even. And behavior, same or different? What is it? Go ahead. Same. Good. Excellent. Okay. So we're going to do the same thing. However, now we have a different graph. But again, I want you to do degree and name, factored form, y-intercept, x-intercepts, and behavior. Because there's a little more of maximins, we're going to do that together. So degree, name, factored form, y-intercept, x-intercept, and behavior. Go ahead. All right. What is my degree and name? Liam? Cubic polynomials, right? Just looking at cubic, that's all. All right. What is factored form? Factored form, factored form. What do we got? Danielle. Good. Remember that when you split the middle, okay, x squared minus 1, x plus 3, you have the difference of 2 squares there. So it could keep going. Okay. What is my y-intercept? Addison. 0, -3. What are my x-intercepts? What are my x-intercepts? Son? Oops. -1, +1, and -3. Good. What is my end behavior? As x approaches negative infinity, where is y? Anybody? Said same people. Emma, as x approaches negative infinity, where is y heading? Excellent. Good. As x approaches positive, where am I heading? Let's see. Same. Yep, perfect. Okay, so I'm just going to plot these guys. Okay. All right. So now we're going to use our calculators to find the exact. So go to y equals, and we're going to type in x, and if you need something larger than squared, you could use the caret here, 3, but remember to take it out of that exponent spot, so press the right arrow, okay? Then you have plus 3x squared minus x minus 3. Okay, everyone okay? Then press graph. Okay, we're going to find the exact. Okay, we have a max and a min here. Okay, and we're rounding to the hundredths place. All right, so we're going to find the maximum first. So second trace, number 4. I'm going to go by x-intercepts. You guys could do left bound, right bound if you want to by moving your cursor. Do -3, enter, -1, enter. I'm going to guess. And then my max, I'll write it on the board so we don't forget. And you guys could write it on your sheets. Okay, there's my maximum. Okay. Yes, Liam.
So the second y equals what's
For what? What are you looking for?
trying
Okay, so second trace.
second trace?
Yep. Second trace and number 4, I think, for the maximum. Okay. So now I'm going to find the minimum. Second trace, number 3, the minimum. Left bound, I'm going to use -1. Right bound, I'm going to use 1. So what it's doing is it's enclosing where that minimum is. Okay? Then I'm going to hit guess. And my minimum, and we're exact, okay, roughly about that. Okay? So I use the x-intercepts. For the maximum, I typed in -3 for left bound, then -1 for right bound, enter for guess. Okay, so we're going to jot those down. Let's see, max. Okay, my max and mins, there's some examples where you're going to see in a little bit, which has more than one. Okay, so you have to do this, get familiar with it. And again, a rough sketch. Okay, so now, where am I increasing? Brayden, where am I increasing? Okay. Increasing is from left to right, so it's from here to here, right? That's the first one. So where would it be? From where to where? Negative infinity. -2.15. Okay, it's the x value of the maximum. And again, the smartboard's a little off. You guys have it easier right in front of you if you jotted this down. Where else am I increasing? Caitlin? Good. Good. Where am I decreasing? Rosanna? Good. Perfect. Okay. Where am I positive? Nolan, where am I positive? Mm-hmm. Okay. Mm-hmm. Perfect. Okay. Where am I negative? Danielle? Yep. Okay. Now it doesn't touch the x-axis at all, meaning it doesn't bounce off. Where does it cross? Should be fairly easy. Where does it cross? Yeah. Yep. Good. What is my domain? Sabrine, what's my domain? God bless you. Good. Blake, where's my range? God bless you. Look at the whole graph on the board. Mm-hmm. Okay. What is the degree of this function? Esteban. 3. Genevieve, change directions. 2. Good. Is the degree even or odd? Grace. Good. Is the end behavior same or different? Taylor. Good. Excellent. Okay. So we just went through 2 examples, okay, of basically the only difference is finding the max and mins in your calculator. You have done everything else, okay? So now you're going to try 2 on your own. If you do not have a calculator, you could always use Desmos if you wanted to, okay? But if you're near somebody, maybe one person do one example, okay? Say number 3, which is the next one. Say one person find the max and mins, and then the other person do number 4, max and mins, okay? So you get some practice with this. If not, then look at Desmos, do your best. So in class, I want you to try number 3 and number 4, okay? I will have the answers up by the end of class up here. So all of 3, all of 4, your homework, okay, if you finish those 2 things, which you might not by the end, is on page 2.9 practice 2, pages 13 through 16, okay? So you're going to start with 3 and 4 in class, going through all this information. Then your homework is the 2.9 practice 2, starting on pages 13 through 16. All right? Let me get started on that. Hold on one second.